Okay, so for the first one, gallons into cubic inches. Okay, so gallons on bottom, 1 gallon, 231 cubic inches. Gallons cancel, and it's 7 times 231, which is 1617. You're off by 3 years, isn't it? 1614? 1814, okay. Milliliters going into liters. From milliliters to liters, we're moving how many spots on our chart? 3 spots to the left. So our decimal point goes 3 spots to the left. So 0.78 liters. 64 cubic feet going into gallons. So yes, it's cubic feet on bottom equals 1 cubic foot is 7.5 gallons. 64 times 7.5 is 480 gallons. Now this next one is here for a reason, because we're going to have to do something here that's going to lead us into our lesson a little bit for tomorrow. We get rid of cups. Cups are going to be on bottom, but we don't have a direct translation, a direct equivalency from cups to gallons. So we're going to have to go from cups to pints. We know that 1 pint is 2 cups. So now the cups cancel out and we're in pints. We go from pints to quarts. What's the relation there? 1 quart is 2 pints. So the pints have canceled out. We're in quarts. We need one more step. Quarts on bottom, gallons on top. Relationship there is 1 gallon is 4 quarts. Remember, quart stands for quarter. So this is 64 divided by 2 is 32. Divided by 2 again is 16. Divided by 4 is 4 gallons. 2.4 liters going to milliliters. How many spots is that? 3. You got to fill in some zeros. 2,400 milliliters. 2,400 cubic centimeters going into liters. A cubic centimeter is equivalent to what? A milliliter. So we're basically going from milliliters to liters. It's 3 spots, 2.4 liters. Now, just like we talked about the difference between capacity and volume. Remember, volume was those multiplied length measurements. So lengths, volume would be cubic inches, cubic feet, cubic centimeters, cubic millimeters, cubic meters and stuff. Capacity was standard containers. But the difference between them is really just how they're measured and how they're computed. They both measure the same thing. They measure how much something holds, how much is within another object. Well, today we're going to talk about the difference between mass and weight. And this one's a little bit more important because there's a little bit bigger difference. Mass is a measure of the amount of matter in an object. That literally means how many particles are in that object, how many atoms are in that object. Weight is a measurement of the force of gravity on an object. The big difference is in how they're measured. Mass is measured with something called a balance. What a balance looks like is a very precision teeter-totter. On one side of it, we put the object we're trying to measure. On the other side, we'll put known masses. And when it balances, whatever this mass is the mass of this object. Weight is measured with a scale. And a scale is really nothing more than a spring. A good spring stretches proportional to the force. If you let it relax and you add a force to it and it stretches, well, if you double the force, it should double the length, that's the amount it stretches. Of course, within the limits of the spring. So we take a spring, and we have some sort of a box on it and an indicator on that spring. And then there's some sort of a numbered scale. That's how the scale is, what the scale is named for, is that numbered scale that measures how far the spring stretches. So we put our object on there. The spring stretches down, the indicator moves. The distance the indicator moves measures the distance the spring stretches, which is equated to a force. Now you might be looking at those and say, both of them use gravity. What's the big deal? Mass is constant. If I go to the moon, where gravity is 1/6 of what it is on Earth, yeah, it's going to change the amount that gravity pulls on this object, but it's also going to change the amount that gravity pulls on the known mass. It's still going to balance. So the mass is going to stay the same. Weight depends on gravity. Because on the moon, this spring is going to stretch only 1/6 of the distance, so the weight will only be 1/6 of what it is on Earth. Now on Earth, we tend to use these interchangeably. There is less than a 10% difference in the force of gravity between the North Pole and the equator. So that means as a person who weighs about 200 pounds at the North Pole will weigh somewhere in the mid 180s at the equator. So there is a difference, but it is close enough that we just assume it to be constant. So we can flop back and forth between mass and weight because it's a pretty constant conversion because we're just dealing with Earth's gravity. In the standard system, we tend to focus on weight, so I'm going to start out with standard mass. Anybody happen to know the unit of mass in the standard system? A slug. One slug is actually about 32 pounds. You probably have heard this before in sayings. There's a whole slug of them over there. I mean, a slug is a relatively large item. You'll probably never see that used in measurement. A lot more familiar with standard weight. We're going to start out with our big unit, the ton. How big is a ton? 2,000 pounds. Well, that is actually something called a net or a short ton, which implies there's something called a gross or long ton. And there is. A gross ton is 2,240 pounds. What's that? No, you'll never actually use that unit anymore. What it is, the ton was originally used for buying and selling grain. But you can't put a ton of grain on a scale without it falling off. You had to have it in a container. The container that held a ton of grain is about 240 pounds. So think of it kind of like your paycheck. If you work 40 hours in a week at $10 an hour, you've earned $400. That's your gross pay. You're not going to get that much. They're going to take out taxes and other crap. You might get $300. That's your net pay. Same here. Gross was the grain and the container. Net was just the amount of grain you got. Yes, in this class, 99.9999% of the time when you hear the word ton, they're talking about 2,000 pounds. In this class, we will never use the long ton. It will always be the short ton or the net ton. Smaller than we got the pounds there. Now notice I abbreviated it LB there. I should have wrote out pounds. It would make sense to abbreviate pounds with PD, but in the bookkeeping system for buying and selling grain, pounds was already used for the abbreviation for paid. So in order to avoid confusing the two, they used the Latin word for pound, which was libra, and that's where the LB comes from. Smaller than a pound is ounce. How many ounces are in a pound? 16 ounces. They continued to use the Latin word for ounce, which I don't remember what it is right now. Abbreviated OZ, yeah. Smaller than an ounce, there is a, sounds similar, but gram is metric. Standard is a dram. There are 16 drams in an ounce. The dram was one of the original apothecary units for medications. You might be prescribed an eighth of a dram of a medication or a 16th of a dram of medication. Drams. And then, of course, grains. For some reason, grains don't go off ounces or drams. They go all the way back up to pounds. There are 7,000 grains in a pound. This is actually literally grains of salt. They would count out the grains. Is that what it is, 540? I know it's not a perfect conversion. Let's divide by 16. 437 and a half, it looks like. Yeah. Actually, grains of salt is what it became, but it was originally grains of sand. Now, a little side note here. Because you hear it all the time on the radio or news or whatever, gold has hit $1,700 an ounce. Well, they're not talking about these ounces. Just, we had talked about how King Edward declared his thumb and foot to be the official measurements and all that stuff. Other kings did the same thing at the same time. That's why the meter is not equivalent to our yard. The meter is equivalent to the Swiss yard. It's equivalent to a yard, just not the one we're used to. Well, other leaders did the same thing throughout the world. So different units, they were the same name, but different units from different place to place. The Center for Buying and Selling Precious Metals. No, you don't need this. This is just for your own knowledge. It was the island of Troy. The island of Troy was just off of the Greek coast in the Mediterranean Sea. It was a hub of trade for pretty much everything, but gold and silver was a big thing at that time. The reason it was such a big deal to have the island of Troy was it was risky at that time for countries to trade with other countries, because these big ships coming into your port, you couldn't tell whether they were carrying gold and silver or soldiers. So you let them into your port, and once they're docked and a couple hundred soldiers come off, nothing you can do. So the island of Troy was offshore, so they could have other boats come in, and if it was an invasion, they weren't invading the mainland of Greece. They could take over the island, and Greeks could come over and take it back. Yeah. But anyway, excuse me, a Troy pound is only about 0.82 of our regular pounds. So it's smaller than our regular pound. However, 1 troy pound only contains 12 troy ounces. So a troy ounce is actually significantly bigger than our ounce. Again, I won't test you on that, but it's just if you're deciding to get into that stuff. Precious metals is actually a decent investment these days. Know that it's different units than what you're used to working with. Metric. In the metric system, we tend to focus on mass. So I'm going to start out talking briefly about metric weight. The unit of weight or force in the metric system is the Newton. The Newton's actually a pretty small unit. 1 kilogram is about 9.8 newtons. Now, you might be looking at that thing, and that's not a neat little conversion. I thought the metric system was supposed to be a nice, neat little conversion, everything being powers of 10. Well, it didn't work out that way because they insisted in the metric system, even in the metric system, they insisted on keeping everything, the relationship between weight and mass is the acceleration of gravity. And when they created the meter, it came out to be 9.8 meters per second squared was the acceleration of gravity. There was talk about adjusting the meter to make it 10 meters per second squared, but then the meter wouldn't be equal to a Swiss yard anymore. It ended up being, they compromised and they left it at that. So metric mass. Our one unit of mass in the metric system is the gram. Now, like our units of capacity, a gram is a planned unit. A gram is defined to be the mass of 1 milliliter of water. Remember, a milliliter is a cubic centimeter. Slightly more than your average paper clip is what that is. It comes out to be. So a gram is abbreviated G. We have decigrams, centigrams, and milligrams. If we skip down, we would also have micrograms, a millionth of a gram. Micrograms getting pretty small. A gram is not that big to begin with. Going larger, we have decagrams, hectograms, kilograms. A kilogram, by the way, we'll talk more about our conversion between metric and standard, but it is about 2.2 pounds. It's like 2.208 or something like that if you really want to go out to it. Bigger than a kilogram, then we skip up to the megagram, which is 1,000,000 grams. What they normally do with the megagram is they refer to it as 1,000 kilograms rather than 1,000,000 grams. And that is what they call 1 metric ton. Now at 2.2 pounds per kilogram, that's about 2,200 pounds in a metric ton, which is 10% more than our standard net ton. But it's close enough to allow for trade between countries and not get too much confusion when we're talking about a ton. Most of the time when you hear commodities trading on the news, on the radio or whatever, they talk about whatever they're selling for so much a ton, they are talking metric tons. Find the mass of the water that this tank can hold. We'll keep it simple this time. Pretend that looks like a tank. Now, first thing we're going to do is find the volume. How do we find the volume of that? 6 meters times 2 meters is an area of a base of 12 meters squared, right? So then the volume is the 12 meters squared times 3 of height, yes. So it's 36 meters cubed. Now, we have this conversion 1 gram of water is the mass of 1 milliliter, a cubic centimeter, basically. So we have to convert this into cubic centimeters. If I convert that to cubic centimeters, 36 cubic meters going into cubic centimeters. Meters to centimeters is 2 spots to the right. Since it's cubic, however, we have to go 6. We got to add zeros. That's 36 million cubic centimeters, which is 36 million milliliters, which is 36 million grams of water, which is how many kilograms? Three spots to the left is 36,000. So that tank is holding 36,000 kilograms of water if it's full. So some pages out of the big book. 255, exercise 8-11, 256, exercise 8-12, page 275, exercise 9-13, and page 276, exercise 9-14.